So we are back, and now we are going to go over our second topic in the Google Data Cloud topics documentation. I think it is useful to go over a data lake. What is a data lake? A data lake is a centralized repository designed to store, process, and secure large amounts of structured, semi-structured, and unstructured data. It can store data in its native format and process any variety of it, ignoring size limits. There's a link here. It says learn about modernizing your data lake on Data Cloud. The data lake. A data lake provides a scalable and secure platform that allows enterprises to ingest any data in any form at any speed, even if the data comes from on-premises, cloud, or edge computing systems. Store any type or volume of data in full fidelity. Process data in real time or batch mode, and analyze data using SQL, Python, R, or any other language, third-party data, or analytics application. A data lake versus a data warehouse. This is important. A data lake is also defined by what it isn't. It's not just storage, and it's not the same as a data warehouse. While data lakes and data warehouses all store data in some capacity, each is optimized for different uses. Consider them complementary rather than competing tools, and companies might need them both. As a point of comparison, data warehouses are often ideal for the kind of repeatable reporting and analysis that's common in business practices, such as monthly sales reports, tracking of sales per region, or website traffic. Do you need a data lake? When determining if your company needs a data lake, keep in mind the types of data you're working with, what you want to do with the data, the complexity of your data acquisition process, and your strategy for data management and governance, as well as the tools and skill sets that exist in your organization. Companies today are also starting to look at the value of data lakes through a different lens. A data lake isn't only about storing full fidelity data, it's also about users gaining a deeper understanding of business situations because they have more context than ever before, allowing them to accelerate analytics experiments. Developed primarily to handle large volumes of big data, companies can typically move raw data via batch and/or stream into a data lake without transforming it. Enterprises rely on data lakes in key ways to help lower the cost of ownership, simplify data management, prepare to incorporate artificial intelligence and machine learning, speed up analytics, and improve security and governance. What are some data lake use cases? Because data lakes provide the foundation for analytics and artificial intelligence, businesses across every industry are using them to increase revenue, save money, and reduce risk. Media and entertainment. So, they're talking about some of the industries here that are using data lakes. So, media and entertainment is one industry, telecommunications is another industry, and financial services is a third industry. Oh, this is very cool. So they also have quite a lot of other products and services that are similar to the data lake idea. So Google Cloud offers a suite of auto-scaling services that enable you to build a data lake that integrates with your existing applications, skills, and IT investments. This includes data flow and cloud data fusion for data ingestion, cloud storage for storage, and Dataproc and BigQuery for data and analytics processing. I am going to take a minute here to talk about data flow. So there's quite a lot of documentation here on how to use it, but basically data flow is a unified stream and batch processing that's serverless, fast, and cost effective. So the benefits here are you get streaming analytics with speed. Data flow enables fast, simplified streaming data pipeline development with lowered data latency. Simplified operations and management. It allows teams to focus on programming instead of managing server clusters, as data flow's serverless approach removes operational overhead from data engineering workloads. That's a really important feature. So managing servers and clusters, scheduling, and the like can take a very long amount of time. So this last benefit, it reduces the total cost of ownership. Resource auto-scaling paired with cost-optimized batch processing capabilities means data flow offers virtually limitless capacity to make your seasonal and spiky workloads without overspending. Okay, so there's like a list here of key features. Let's go to view all features. This is really cool. Okay, so let's just go through these. And again, we're talking about data flow. So vertical auto scaling, which is new in Data Flow Prime. This dynamically adjusts the compute capacity allowed to each worker based on utilization. Workers are like compute clusters. They're like computers, basically. Vertical auto-scaling works hand-in-hand with horizontal auto-scaling to seamlessly scale workers to best fit the needs of the pipeline. Right fitting, new in Data Flow Prime. Right fitting creates stage-specific pools of resources that are optimized for each stage to reduce resource wastage. Smart diagnostics, new in Data Flow Prime. A suite of features including 1, slow-based data pipeline management, job visualization capabilities that provide users a visual way to inspect their job graph and identify bottlenecks. 3, automatic recommendations to identify and tune performance and availability problems. Then there is a streaming engine. Streaming engine separates compute from state storage and moves parts of the pipeline execution out of the worker VMs and into the data flow service backend, significantly improving auto-scaling and data latency. Horizontal auto-scaling. Horizontal auto-scaling lets data flow service automatically choose the appropriate number of worker instances required to run your job. The data flow service may also dynamically reallocate more workers or fewer workers during runtime to account for the characteristics of your job. Data flow shuffle. It's a service-based data flow shuffle, moves the shuffle operation used for grouping and joining data out of the worker VMs and into the data flow service backend for batch pipelines. Batch pipelines scale seamlessly without any tuning required into hundreds of terabytes. Oh wow. Data Flow SQL. Data Flow SQL lets you use your SQL skills to develop streaming data flow pipelines right from the BigQuery Rev UI. You can join streaming data from PubSub with files in cloud storage or tables in BigQuery, write results into BigQuery, and build real-time dashboards using Google Sheets or other BI tools. A flexible resource scheduling, or FlexRS. Data flow FlexRS reduces batch processing costs by using advanced scheduling techniques, the data flow shuffle service, and a combination of preemptible virtual machine VM instances and regular VMs. And then there's data flow templates. Data flow templates allow you to easily share your pipelines with team members and across your organization, or take advantage of many Google-provided templates to implement simple but useful data processing tasks. This includes change data capture templates for streaming analytics use cases. With Flex templates, you can create a template out of any data flow pipeline. That's actually pretty cool. Notebooks integration. Iteratively build pipelines from the ground up with Vertex AI notebooks and deploy with the data flow runner. Author Apache Beam pipeline step by step by inspecting pipeline graphs in a read eval print loop REPL workflow. Available through Google's Vertex AI, Notebooks allows you to write pipelines in an intuitive environment with the latest data science and machine learning frameworks. Real-time change data capture. Synchronize or replicate data reliability and with minimal latency across heterogeneous data sources to power streaming analytics. Extensible data flow templates integrate with DataStream to replicate data from cloud storage into BigQuery, PostgreSQL, or Cloud Spanner. Apache Beam's DBZM connector gives an open source option to ingest data changes from MySQL, PostgreSQL, SQL Server, and DB2. Inline monitoring. Data flow inline monitoring lets you directly access job metrics to help with troubleshooting batch and stream pipelines. You can access monitoring charts at both the step and worker level visibility and set alerts for conditions such as stale data and high system latency. Customer managed encryption keys. You can create a batch or streaming pipeline that is protected. That is protected with a customer managed encryption key, or access CMEC protected data in sources and sinks. Dataflow VPC service controls. Dataflow's integration with VPC service controls provides additional security for your data processing environment by improving your ability to mitigate the risk of data exfiltration. Private IPs. Turning off public IPs allows you to better secure your data processing infrastructure. By not using public IP addresses for your data flow workers, you also lower the number of public IP addresses you consume against your Google Cloud project quota. Interesting, okay. So we learned a lot there.